creating a flex model. Together we are going to build a model to evaluate the allocation of capacity across departments. This way, you will soon be able to determine for yourself the probability of shortage with the chosen allocation and the impact of flexibilization or a joint shared department. Specialty 1 has 11 beds. Specialty 2 has 5 beds. They are short of that in 4.1% of the days and 4.5% respectively. But what if they both surrender a bed and use it as a joint shared capacity? Then both specialties improve. The number of days shortage decreases for both specialties. Before we start modeling, how does the principle of flexibility or shared capacity work? We look at two groups of patients, G1 and G2. Those groups require a certain amount of capacity, DG1 and DG2. Group 1 has an allocated amount of capacity of CG1 that can only be used by Group 1, and Group 2 has an allocated capacity of CG2 that can only be used by Group 2. There's also a shared capacity called C-flex that can be used by both groups of patients. This happens once the capacity on CG1 and or CG2 is fully utilized. Then the remaining part passes to the flexible or joint capacity. The demand for joint capacity is D-flex, and thus is the sum of all demands that cannot be done on CG1 and CG2. An example: the demand is 7 from Group 1, while its own capacity is 5. Therefore, another demand with size 2 will overflow through the joint shared capacity. But Group 2's demand is also bigger than its own capacity. Therefore, one more will flow through to the joint capacity. Therefore, the total demand for the joint capacity is 3. Since the shared capacity is sufficiently large to handle the demand, there's therefore sufficient total capacity. We look at some other examples. In this case, both groups' demand is less than or equal to their own capacity, so there is sufficient capacity anyway. In this case, Group 1's demand is bigger than its own capacity, but the total demand for joint capacity is less than the available capacity over there, so there is sufficient capacity in the end. In this other case, Group 1's demand is much larger than its own capacity, but its demand for joint capacity is also larger than what is available over there. So Group 1 has a shortage of capacity at that time. Group 2, however, has no shortage because their own capacity is simply sufficient. So only if its own capacity is insufficient and at the same time the total demand for the joint capacity is bigger than C-flex, then there is a shortage for that particular group. Here's an example that both groups are short of their own capacity, but the joint capacity is sufficient so that there is a sufficient capacity overall. In the last example, the demand is bigger than the own capacity for both groups, and the demand for the joint capacity is bigger than the available capacity C-flex over there. So the combined capacity is not large enough for the demand of both groups. It is then fair to say that both groups will be short of capacity in this case. Now, we will then create the model. Also check the description. There's a link where you can download the model directly. In column A are dates. In column B is the demand for specialty 1, and in column C is the demand for specialty 2. In this case, it is demand for beds or historical patient census. But you could just easily put the demand for staff there. To calculate the probability of shortage for both specialties, as we saw earlier, we need the following columns or information. Whether there is a shortage of own capacity for both specialties, the total demand for the joint capacity, the parts that cannot be provided with its own capacity, and whether the joint capacity is in short supply. After all, only if both the own capacity and the joint capacity turn out to be insufficient, then the specialty is short of capacity.
So for specialty 1, when is the own capacity not enough? That's only in the case if the demand for specialty 1 exceeds the own capacity. Then we put a 1, otherwise we put a 0. The same is true for specialty 2. So if the demand for specialty 2 exceeds the capacity that we have for specialty 2, their own capacity, then we have a 1, otherwise we have a 0. So let's look at this. So here we have a date where the own capacity is not sufficient to handle all demand, because the demand is 11, we have an own capacity of 10, so there is a shortage indeed. Here as well, the demand is 15, we have an own capacity of 10, so there is a shortage. So note that the 0 and 1s indicate whether there is a shortage or not. So when there is a shortage, the amount that cannot be done within their own capacity, within their own department or ward, that surplus amount will flow through to the shared department. So we have to calculate what is the amount that will flow to the shared department. So that happens only if there is a shortage on their own department. So if that equals 1, then what is that amount? It's the demand minus the capacity on their own department. Otherwise, it's 0. Plus, when specialty 2 has not enough own demand, then what will flow through to the shared department? That's the demand of specialty 2 minus the capacity, which is only available for specialty 2. And if there's no shortage on their own ward or own department, then 0 will flow through to the shared department. So here we have an example. There's a shortage for specialty 1 on their own department. So we have 10 capacity, the demand is 15, so 5 demand will flow through to the shared departments. Is there a shortage on this flexible department? Well, we have to take the available capacity into account. So here we do the same as we did before. If the demand for this flexible capacity exceeds the capacity that we have, then there is a shortage, otherwise there's no shortage. So this is an example, and there's not enough own capacity for specialty 1. There's also not enough capacity on the flexible ward, so there is a shortage for specialty 1. Not for specialty 2, because their own capacity is large enough. Here, for example, there is a shortage on their own capacity for specialty 2, but this is a very small shortage, so it can be met from the shared departments. So in the end, there is no shortage for specialty 1 and for specialty 2. So let's fill this in. So the sum of all the above. So we have 16 beds, 16 capacity in total. What is the shortage for specialty 1? Count ifs. There is only a shortage if the own capacity is not sufficiently large, and at the same time the flexible capacity or the shared capacity is also not big enough. So if there is a shortage on both the own department and at the same time on the flexible department. So it happens 8 times out of all these entries here on the left. The same for specialty 2. So there should be a shortage on their own capacity and at the same time a shortage on the shared departments. It happens 5 out of those times on the left. So what is the probability of shortage? It's the amount that it occurs divided by the number of entries that we have. So based on this allocation of a capacity of 10 allocated for specialty 1 only, 4 allocated for specialty 2 only, and 2 shared beds, 2 shared capacities, with total 16 beds, there's a shortage probability of 3.3% for specialty 1 and 2.1% for specialty 2. So what happens if we don't have a flexible ward? Then, for example, specialty 1 gets 11 beds, this one gets 5 beds, here we have no beds, and then we have a probability of shortage that is higher than what we have seen before. So only a little bit of flexibility increases the performance for both specialties in this case.
Now that the model is ready, you can work with it yourself. If you found this an interesting video, please subscribe to my channel for more interesting videos. See you next time.